Welcome everybody to the latest installment with Desco. Need to show you my screen. Latest installment of measuring resistance in an ESD or an EPA environment. My name is Greg Heckler, and I'm going to introduce myself properly in a second here. Again, I'm the Western Regional Sales Manager for Desco. Our moderator today is Jeffrey Brake, our Desco Brand Manager. And you're going to have questions, I'm sure. I hope you do. Just refer to the toolbar on the right side of your presentation there and ask your questions throughout the presentation, and then we'll break a couple of times for answers. So an overview, we're going to be talking again, like as I mentioned, about measuring resistance in an ESD control plan or your EPA, which is electrostatic protected area. And just about every technical requirement in a static control program, but ionizers, for instance, you have to measure the electrical resistance of those products, not only for qualification, but on a periodic basis. So we're going to be teaching you about the different resistance meter types and their features and how to use them. And then I'm going to show you some tips also, especially these come in handy when you have a larger facility with a lot of things to test. So one of the most common types of measurements that you're going to be doing in a static control environment is what we call resistance to ground, or RTG for short. And you're going to perform this measurement on just about everything in your environment that is groundable and should be grounded. So that's one of the measurements I'm going to demonstrate for you today. And I have a bunch of different products to do that. Another type is what we call point-to-point resistance, or RTT. And this is when we're going to measure surface resistance only. And that will apply to groundable things, but also to packaging materials also that typically, like ESD bags, for instance, that typically aren't grounded. And so I'm going to demonstrate both of these types of measurements using all the various types of test equipment. So I'm going to do this in accordance with the ESD Association's S20.20-2014 standard. 2014, if you're not familiar with this standard, is the latest revision. And in this document, there are a number of tables, Table 2 and Table 3, that lists all of the maximum resistance numbers that you need to stay below, if you will. And so, for instance, in this area right here, it not only shows you the measurements for product qualification, but it also shows you the measurements for compliance verification. Now, these are distinctly different testing methods. Product qualification is if you wanted to test your own materials. Maybe you were testing a number of different brands and you wanted to choose the best one out of those. Product or compliance verification is after I put that product into use. Now, the numbers may be the same, but the technique of measure them is a little bit different in that we don't need to control temperature and humidity, and we don't need to have multiple sample sizes, for instance. So these are the other tables that I was talking about. So every technical requirement, and when I say technical requirement, I mean wearing a wrist strap, grounding the body, ESD flooring, chairs, smocks, etc. Each one of those technical requirements has a resistance number associated to it, and I'm going to demonstrate those. So there are different resistance meter types. The basic meter that we have is basically a resistance checker. And this will allow you to check surface resistance, and if you have the optional 5-pound weights and leads, it will also allow you to check resistance to ground. The primary difference with this is pretty much a basic unit, and it has an accuracy of about 2 decades, something like that. So this is your most basic type of resistance checker. Then next level up from there would be a traditional analog type of tester that you can see has the needle here, and you see on the scale these numbers refer to the exponent up there, and this adds a few more features in that it also has the 10 and 100 volt capability, but it also has auto voltage switching, so it will sense when it needs to switch from 10 and 100 volts, and I'm going to get into that more. And this tester then steps up to 1 decade of accuracy. So that's the next level. And then we have our most feature-packed digital instrument. And digital instruments obviously are the most accurate types of meters that you can purchase. So if you want to be as close as you can to that, whatever you want that number to be, the digital is the way to go. And that adds a number of other features, which I'm going to get into. This is the meter that I'm going to be using today to demonstrate everything we need to do. So I'm going to break just real quick and see if you have any questions. Jeffrey, do we have any so far?
Greg, can you clarify the difference between compliance verification and product qualification from the S2020?
Okay, so again, as I mentioned before, product qualification is I haven't purchased the product yet and I haven't put it into use. And I'm deciding whether, and it doesn't matter whether you're choosing multiple brands or you're just looking at one. But product qualification would be making sure that this product is suitable for use in your environment. Not only meets the ESD Association requirements, but maybe other requirements, maybe cleanliness or something like that. And there are specific standards for that. These standards are referred to in the S2020. And so, as an example, if I wanted to qualify ESD mats, I need to have multiple. I need to have multiple sample sizes. I need to control temperature and humidity, and then I go through the proper, fixed qualification process as far as where to put my weights, voltage, things like that. But after I install that product, let's say an ESD mat on my work surface, now it becomes compliance verification. So everything else is good. I just need to know, for instance, what the resistance to ground is of that material. And that's one of the things I'm going to show you. So don't confuse the two after you've installed your product, because if you're doing product qualification, once you installed it, you're making a whole bunch of work for yourself. Another question, Jeffrey?
Yeah, there's a question about on the digital surface resistance meter, the one you're going to use today, why at the greater than 10 to the 12th range is the accuracy only plus minus 20% compared to 10% at the lower ranges?
Well, that's because that as resistance steps up, I mean, we all understand resistance, I think, here, but as the resistance goes higher, it takes much more time for that test voltage to get through that resistance, if you will. And so because of that, we not only need to test longer, which is something I'm going to show you too, or apply that voltage longer for a longer period of time, but accuracy falls off. So keep that in mind, that if you are really big on extreme accuracy, you're going to see a drop off in that as the resistance of your materials gets higher. Another question?
That's it. I think for now. Please continue to ask the questions as we go here. Greg will stop a few more times. So
okay.
Let's go ahead.
Okay. So now
at
this point in time, oops, I'm sorry, Jeffrey. Go ahead.
Yeah, let's go ahead and move to the live demonstrations.
Okay. So you should see my camera now. So what I'm showing you here now is a demonstration. I have a workstation set up with a whole bunch of different things to test that we would typically use in a static control environment. I have all my test equipment. I have a number of different testing accessories too you need to use if you want to meet the requirements of the ESD Association standard. Again, I'm going to be using my digital tester, the Desco 19290. That's the test kit comes with the leads. It has the 2 5-pound weights, and it also has this little handy dandy ground adapter that allows me to pick up an AC ground conveniently. So I'm going to be using that. I also have what we call a concentric ring probe. And this tester or probe is used when I'm testing surface resistance on planar materials. Basically anything flat and large enough that I can fit this probe on. So this is like having two probes in one. As you can see, there's an inner test point here, and there's an outer test ring here. Now what this does is measures the resistance between these 2 points. And so this is basically what we call measuring ohms squared. Now it just so happens this is the distance, but that could be an inch, that could be 5 inches, that could be a foot, whatever it is. So this is a concentric ring probe, and we typically use that to measure packaging materials like ESD bags, bin boxes, which I have, things like that. Another test probe that I have, it's what's called a 2-point probe. And this one allows you to measure much smaller things that either your 5-pound weights or your concentric ring probe won't fit on or into. So for instance, this connector cap, I'd never get that 5-pound weight in there, so I can fit this conveniently down inside that cap to measure that. So that's another tool that you might use, 2-point probe. I also have what's called a glove test fixture here. Now, in the standard, there's also what we call a CAFE standard, and that CAFE standard is used to measure gloves while they're being worn. And if you want to do that by the book, you need to have what's called this CAFE text fixture. Then I have another test probe here, and this is used when we want to measure the resistance of the human body to ground, which I'm going to show you. Now, I've been talking about the S20.20 standard here, but there's also, for compliance verification, what we call ESD TR53. And TR53 is the document that we use that tells you how to use all this test equipment, where to put your probes, how to use this, the equipment to use, etc. So that's the document that you're going to refer to. I want to mention one other one before I forget too. The S2020 does not cover the requirements of packaging materials. They refer to what we call S541 for that. So if you want to know everything you need to know about testing an anti-static bag or a static shielding bag and everything, it's S541. But using this equipment, I'm going to give you an example of some of those tests that you can make. So I'm going to get started here. I've got a cheat sheet here, and I got my trusty assistant. You can't see Stephen Lopez here. He's going to remind me because we have a lot of things to test. So what's our first thing we want to test, Stephen? Okay, so we're going to test work surface. We're going to test RTG and RTT of that. So I'm going to turn my tester on. I'm going to show you how this cycles up, and I'm going to point out the features of this as we go. So as you can see, the LEDs scroll across the top. We also have this nice bright OLED monitor here for the Mantissa, or the fraction of the exponent measurement. And I'm going to get into some of the other test requirements also in a minute. So the first thing I'm going to start with, and this is the mandatory test requirement for testing an ESD workstation, and that's what we call our ESD Work Surface. That's what we call resistance to ground. Okay, so in the case of this tester, my red lead is the voltage lead. So I'm going to put that on the front edge of my mat here. I'm going to use my handy dandy little ground connector here. And I'm going to plug this into my AC ground. And just so you know, the ESD work surface is grounded also to the AC ground. So now I have a resistive loop, and I'm going to take my measurement. Now, one of the things I understand, we get this question a lot. How many places do I have to test? Well, that's user definable. If I only work in this 1 or 2 square feet, that's the only place you need to test. But if you want to test back left, back right, whatever you need to do. But the only time you have a required number of tests is on the qualification side. So for our purposes, I'm just going to test this front end. So I'm going to press my button. And one of the things I'm going to point out while we're waiting for our measurement is that the standard requires that if something is conductive, and that is less than 1 times 10 to the 5th, that you apply 10 volts to that test measurement. If it's over that number, you need to apply 100 volts for 15 seconds. So the auto features on that other analog tester and this one automatically do that for you. So as you can see, my measurement is 3.39 times 10 to the 6th. Now the requirement for resistance to ground of an ESD work surface is less than 1 times 10 to the 9th. So this material is well within spec. What I want to show you is RTT. Let's say this measurement failed. Let's say it was 1 times 10 to the 11th and it was out of spec. So the first thing I would want to do is I want to make sure the surface resistance of the mat is good. So I'm going to come back here. I'm going to take my other 5-pound probe. Now, when I'm checking RTT of work surfaces, the requirement is that I set my probes 10 inches apart. So we make this cool little adapter here that's set at 10 inches, and I can simply clip on my probes here and I get my exact 10 inches. So that might make life convenient for you. Again, I'm going to take my measurement, and I got to wait the required time. And you'll notice on this tester, it's telling you it's 100 volts. You can also see the temperature and humidity, and there's a battery check level up at the top left. So 7.63 times 10 to the 6th. Now, one of the things you may notice is that number is higher than my RTG. The reason for that is because I'm only checking the top dissipative layer. When I check resistance to ground, I'm not only checking the surface resistance, I'm checking the volume resistance of the conductive ground plane here, and I'm checking the resistance to ground. So the RTG number will always be lower than the RTT number. But the surface is in spec, so that's not the problem. If I had a problem, maybe a ground cord was laying on the floor, something else. But this is not mandatory, only RTG is mandatory. What do we have next, Steve?
What about the work surface bottom?
Okay, so here's another little trick here. Let's say that you use continuous wrist strap monitors. Well, a continuous wrist strap monitor, or most of them, certainly Desco's, they not only measure the resistance of the human body to ground, but they also measure the resistance to ground, or the resistance between two ground points on an ESD work surface. And that every tester has a maximum amount of resistance built into that tester. In this case, it's 10 megohms. So one of the things you may need to do is verify that the ESD mat material that you have is under that 10 megohm number. So you'll notice that this has a color dissipative side and it has a black conductive side. When you're monitoring a work surface, you're only monitoring between two connection points or a connection point to ground. So one of the things you can do with your surface resistance tester is I can use that to confirm if this mat material is in spec. And so we'll wait for the measurement, 8.32 times 10 to the third. So obviously that's only 1,000 ohms, or up to about 10,000 ohms. So that's well within the requirement of being able to work with a continuous monitor. So that's another little trick. Okay, Steve, next.
What about testing a foot grounder for resistor tip?
Foot grounder? Oh, okay. You know what? I can't. We're going to skip that one. I was going to show you because I don't have an extra. Well, maybe I do. Let me check real quick. Yes, I think I do. Okay, so we often get a question or questions about, get a call and people say, oh, everybody's failing on our foot grounder tester. They're wearing ESD shoes or they're wearing foot grounders or whatever. We're all failing high, or some people are failing high. And we typically get these questions as the temperature drops and humidity drops. And oftentimes early in the morning, you get into work, 6:30 in the morning, 7 o'clock, you haven't started sweating. And if you're not sweating, you're not making good contact with the tab of your foot grounder. And so the first thing you got to do, though, is rule out that it's either not the shoe or the foot grounder. So one of the things you can use your resistance tester for is, I can take, this is a full coverage foot grounder, I can take and put one of my 5-pound weights on the conductive material, and then I can put a 5-pound weight on the ground tab here and take my measurement and see if that's in spec. So again, we're waiting our required time. So 1.92 times 10 to the 6th, well within spec. Now, notice I said this is a conductive material and this is a conductive tab. Why do I have 10 to the 6th? The reason for that is because every personal ground product, like a foot grounder and a wrist strap, has a 1 megohm safety resistor in there. So I'm measuring at least that 1 megohm of safety resistance. So that's a nice little trick if you want to confirm that your foot grounders or your ESD shoes or something are not the problem. Okay, next, Steve.
How about the cutting board using the concentric ring probe?
Okay, so you'll see here that I have this white kitchen cutting board on my work surface. When you're measuring surface resistance of something, particularly packaging materials and ESD smocks, which I'm going to talk to you about, you need to isolate those materials from a ground point, or let's say your ESD mat. So you wouldn't want to check the resistance of your static shielding bag while it's sitting on the ESD mat. So the standard requires that I have a surface that's greater than 1 times 10 to the 13th. However, it's very difficult to find something that high in resistance, and certainly large enough if I wanted to test a big bag or something like that. So a kitchen cutting board typically is over 10 to the 12th, and it makes a really good surface for doing that. So I'm going to show you that. So I got a static shielding bag here, common metal in static shielding bag. I'm going to switch to my concentric ring probe now, because again, I only want to know what the surface resistance of the bag is. And the reason I'm concerned about that is because resistance will and can equate to charge generation. So the reason we make static shielding bags or ESD packaging materials dissipative on the outside and inside is so when something rubs up against them, I slide a circuit board in and out, for instance, or I rub this on my clothes, that they minimize charge generation. So again, I'm going to use my concentric ring probe, take my measurement. Now the standard for this number is less than 1 times 10 to the 11th. So I'm going to test. Okay, 1.72 times 10 to the 9th. So well within spec. Now one other little trick. Where do your bags take most of their abuse? Typically, yes, on the outside, but also in the inside, especially if you're using zipper bags or you're reusing them. So be sure to test the inside of your static shielding bags as well, because that's where you're sliding your circuit cards inside and out with those. And we're going to take another measurement. Again, 4.99 times 10 to the 9th. So that's one thing. I might test couple other little things while I have this. Here's a typical sheet protector or shop traveler. You'd want to measure foam materials. Now, one of the reasons I mentioned things like bubble wrap, pink foam like this, for instance, and the importance of testing these periodically is because these types of materials are almost never identified. The standard requires that I identify my ESD materials, typically with that reaching hand, like the one on my smock here. So you're never going to see this kind of stuff identified. So you want to be making regular periodic verification measurements of materials like this. So I'm going to test this pink bubble. Okay, 3.3 times 10 to the 9th. So that's well within spec at less than 1 times 10 to the 11th. All right. So that's another surface resistance measurement you can do with your concentric ring probe. Something else, Steve?
How about the Mantissa bottles?
Okay, I have over here a couple of chemical dispensing bottles. This is a product called a Mantissa bottle. This is one of our companies that we own, and it's a very common product on the ESD workstation. This one here is just a regular clear material or regular non-ESD material, and this one here is the blue static dissipative material. So I'm going to show you one of the features on the tester. Again, this surface is large enough that I can fit my concentric ring probe on. So if I didn't know whether this was ESD or not, I'm going to take a measurement and see if it is. So notice the white bar. That's when we're starting to get up over that 10 to the 12th resistance number, okay? Now I'm going to let that go, but I can also override it, which I'm going to show you in a minute. So let me let this go through because we need all that extra time and voltage. Oh well, so that means it's over the limit. So we know that this is not an ESD material. So I'm going to take one more test. I'm going to show you when this pops back up again, what we can do. This tester has a feature where I can override that length. And so again, my OL pops right up if you choose to do that. So that's another nice feature of the digital instrument. So for the dissipative one, again, let's see if our product is what we say it is. So this one, these are products that are typically 10 to the 9th. Yeah, 1.32 times 10 to the 9th. So that's a perfect type of product to use in your EPA. Another test, Steve?
Yeah, how about you show how to test some smaller items like the reel tape?
Okay, so let's move to our 2-point probe now. And again, this is just a mini version of our other 5-pound weights. So it has this same type of connector here with my black and red terminal banana jacks. So now I have this little mini tester here, and I'm going to test this. This is some tape off of a reel that I also have here, and I'm going to get Trying to make a good connection point here because this is very small, this area. Oops. If it doesn't test, then I'm gonna have to relocate it because this area is pretty small. Okay, I gotta relocate it. Hang on one second. Let's try this again. There we go. 2.10 times 10 to the fifth. So that would let me know, obviously there's no reaching hand on this. There's nothing that says ESD safe. So I want to use these types of tools to verify that it is what the manufacturer says it is. I'm not going to test everything here, but this would be another perfect example of what to use a 2-point probe for. Testing down inside a cavity, because not everything is just a planar surface. Sometimes there's peaks and valleys, or, you know, like I said, inside this cup, where I might have to get down inside something that I want to use to, I want to use this tester to test with. Okay, Steve, where should we go next?
How can we show the glove test fixture?
Okay, so I mentioned this CAFE standard, and not some gloves like this one are purposely made ESD protective, but sometimes you got to test nitrile. Nitrile is naturally dissipative, or there might be other types of gloves, or finger cuts, for instance. And the requirement for testing gloves and finger cuts is a fingertip to resistance measurement. We also need to apply some weight, like we apply weight when we apply to a work surface. So we use what we call a glove test fixture for that, okay? And so I'm gonna put my wrist strap on. Oh wait, plug this in, okay? And you need to wear the glove on the same hand as your wrist strap, for instance. So I'm going to plug this in, and then I'm going to plug my lead into a groundable point. Now I have a resistive loop, and I pick my glove test fixture up like this. And I'm going to measure. Again, it's switching to 100 volts. 2.64 times 10 to the 6th. So well within the manufacturer spec, and I know this is an ESD protective glove. So if you want to test gloves in your EPA, by the book, you need the glove test fixture. What's next, Steve? Okay, so let's break a second for questions. Jeffrey, do we have any questions?
We do. Do you have a shielding bag there?
Yes.
Can you show us how to test that?
Oh, okay, yeah, all righty. So again, we need to test on an insulative surface, and we need to use our concentric ring probe for checking surface resistance. Now, keep in mind, there's two ESD control properties of a static shielding bag. There's the shielding capability of it. That's the metal in here. Then there's the surface resistance requirement to make sure that it doesn't tribocharge or generate a charge. You can't test the shielding effectiveness of a shielding bag with this type of equipment. So right now we're only measuring the surface resistance of the material. So again, I'm going to put my concentric ring probe on the surface, test my surface, and the measurement should be less than 1 times 10 to the 11th, and we've got 3.06 times 10 to the 9th. So well within spec. And as I showed you before, you also want to test the inside of the bag also. It's very important. Any other questions, Jeffrey?
Do you have any cutters or tweezers there?
I don't, but there's a couple of different ways you need to test tools. One, if they should be grounded, if these are conductive tools like a cutter, plier, metal, tweezer, etc. If I want to check the surface resistance of that tool, again, if I could fit my concentric ring probe on there, I could do that. If I had a very fine tip tweezer, I might use my 2-point probe to do that. So it's the same measurement. If I wanted to check if while I was holding that cutter, if it's grounded, then I could do a measurement, which I'm going to show you in a minute, to show body voltage. Any other questions?
Can you test those bottles, those Minda bottles?
Okay, I can test one more time.
Oh, did you already do that?
Yeah,
Maybe
I already
somebody
did
missed
that.
it. Okay. Okay.
Yeah,
And
I
we're probably
already did
good.
that. So that'll be on the that'll be on the recording.
Let's go ahead and you're going to move to the flooring test now, right? There's some questions about flooring, so why don't you go ahead and do those, and
Okay.
hopefully we'll answer those questions as part of that. Thanks, Craig.
Okay, so there are a few other things in your static control program as far as the technical requirements is concerned, and I have a couple of more set up here. I have ESD floor set up. As you can see down here, this is what we call our select tile. It's a snap together floor. So I have a conductive version, a gray dissipative version. I also have a cart that's grounded to the floor via this drag chain. It also has an ESD caster on there. So I'm going to show you how to measure the resistance of ground of that cart to the floor. I'm also going to show you how to measure my body's resistance to that floor. So as far as when we're measuring things like a cart or the floor itself, again, for compliance verification, the mandatory test requirements are resistance to ground. I can show you how to do the RTT, but the mandatory requirement is resistance to ground. So my floor here is grounded back to an AC outlet on the other side of the room. But your AC ground is basically universal within your environment. So I'm going to plug my other test lead into the same ground point that I did my mat ground. And I set my 5-pound weight up on top of the cart. Now I'm not going to do every measurement for a cart, but you would measure each shelf, for instance. So I'm going to verify, I want to verify that not only is the cart grounded to the floor properly, but also within spec. And the spec is less than 1 × 10⁹ Rtg. So 1.16 × 10⁶, well within that standard. Now you might have also, your carts may have dissipative matting on them, or your tray liners, things like that. And again, you would just put this weight on whatever surface you have. As I mentioned, if I find that was out of spec, now I'm going to work backwards. I'm going to go check the RTT of the surface. I'm going to check the resistance to ground or the RTT of the floor, because I want to find out which is the weak link. Maybe I got a bad ground, maybe my floor is out of spec, whatever. But the mandatory requirement to start with is RTG. So let me check should we do floor next, Steve? So again, I've got my standard universal AC ground. Now I'm going to put my 5-pound weight on the floor. And it's important to understand, a lot of people make this mistake when they're checking their carts or when they're checking their floor, specifically carts. They'll put their 5-pound weight on the cart, and then they'll put the other 5-pound weight on the floor. That's not resistance to ground. Resistance to ground is the ground wherever your ESD ground is, or where that floor is grounded to. So I have to put that back here where you can see it. So again, I'm going to run my measurement on the floor, and a floor should be less than 1 × 10⁹. You can see that this is a conductive floor, 10⁴. That measurement came up very fast. You'll also notice that it switched to 10 volts. So that's an important thing. This meter is doing everything you need to do for you, making your life a whole lot easier. Okay, what's next, Steve?
You want to show how to use the spacer?
Okay, so let's say, I'm going to take my wrist strap off a second. Let's say that measurement failed, and I wanted to confirm or make sure that it's not the floor that's the problem. Well, I mentioned earlier that when I check ESD work surfaces, I need to keep my probes at 10 inches apart. When I check flooring materials, the requirement is that I keep them 36 inches apart. So we built this other one that spans 36 inches. So I'm going to put this down here, one probe here, and I'm going to put another probe as far as I can get it on this floor here. All right, span the 36. Plug my test leads in real quick. I don't know if you can see this well, but I've got the probes on the floor 36 inches apart. I'm going to have to unplug this in a minute to show you actually the measurement. So I'm going to take it. Okay, so that measurement was 2.26 × 10⁴. So well within spec for a conductive floor. Now, let me make a point as to why the 36 inches. The reason for that is because that was originally set up for when you were checking ESD tiles. So what we want to make sure is that each tile is connected together properly via the conductive ground plane, or what is typically a conductive adhesive. In the case of the snap together floor, that also proves that all the tiles are touching when they're snapped together. So that's why you need to measure at a longer distance than you do a work surface. What's next, Steve?
Since we're on the floor, do you want to do the fluid body resistance to the floor?
Okay. So now what I might want to know, excuse me, is when I'm wearing a wrist strap for personal grounding, or when I'm wearing ESD footwear for personal grounding, the standard requires that your human body also be at a maximum resistance number. For a wrist strap, it's less than 35 megohm, or 3.5 times 10 to the 7th. For footwear, whether it's ESD shoes or foot grounders, it's less than 1 times 10 to the 9th, or 1 gigohm. When you stand on your footwear tester and you press that button, inside that tester, those limits are built into the tester. When I get a green pass, I'm under that number and I move on, I go to work. But if I actually want to know what my body's resistance is, I can use this little probe that we have here, and this complies to the requirements of TR53. And again, I'm going to take my black lead and I'll plug into a ground point. Okay. Now I'm going to stand on my tester. So now I got a resistive loop back to ground. I'm going to make my measurement, and I'll have to show you this in a minute. I get my test. Okay. 7.37 times 10 to the 5th. Now, one of the points I want to make on this is I got 1 megohm safety resistors in my foot grounders, but I measured less than 1 times 10 to the 6th. And the reason for that is I was standing on the floor with both feet. When you test resistance in parallel, it's about half the number of resistance in series. So I'm only going to stand with 1 shoe on the mat now, or 1 foot on the mat, and do that test again. Sometimes people get confused about that. So notice I'm 1.40 times 10 to the 6th. So when you test like this, you should pick up a foot, so you're testing each foot's resistance independently of each other. Another test, Steve?
How about the extension cord trick?
Okay, glad you asked. All right, so I got this little trick. If you have quite a few benches, a number of benches, maybe you got a lot of carts to test, and you're using AC as your groundable point. Sometimes, you know, all of our companies, I dare you to find an open outlet on one of your workstations right now. So we can't always find an easy access to an outlet. So you can get yourself a 25-foot extension cord, and you can plug in one of our ground adapters, whether it's that one or this one. The nice thing about this tester is it analyzes the AC circuit to make sure that it's safe, and it also gives you multiple ground connections. So what I can do is I can just take my red lead or red probe with me, okay, and I plug my black lead into this ground point, and now I can just carry my ground with me as I go. So I can check over here, I can check there, I can check 30 feet away or 25 feet, whatever your extension cord is. So it's a great way just to drag a ground with you when you're doing multiple measurements. Okay, Steve, next.
Can you show us how to check that smock that's in here?
Okay, so as I mentioned, everything in a static control environment, all the technical requirements need to be tested for their resistance. In the case of garments, we need to check what we call sleeve to sleeve resistance. So cupped at the end of the sleeve, whether you've got an ESD cuff or whether you have a snap type of open sleeve, you need to check the resistance between those 2 points. Now, the smock requirement is one of the more confusing ones because there's 3 acceptable garments. There's static control, needs to be less than 10 to the 10th. That's basically a smock that I don't want to generate a charge. There's a groundable smock, meaning that it's less than 1 times 10 to the 9th and can and should be grounded. Then there's a groundable static control garment system, meaning I'm going to attach my wrist strap cord to my smock, and I'm going to wear my smock like a wrist strap. And so in order for the groundable smock and the static control garment system to work, I need to make sure that all the components of my garment are touching. I also, as that smock gets more conductive, it acts like more of a static shield to keep the static from my clothing from getting out. So I need to make sure the sleeves are connected to the body and all these components are touching properly. So if you were to go again, refer to TR53, you would see that TR53 has these little clamps here that you attach to your sleeve. Now, one of the reasons that they use these is to make sure it's easy to isolate the garment from ground. I could use my 5-pound weights on each sleeve if I want to, but I need to find a place, or like a conference table or something, where I can spread that smock out. You don't want to test it on your ESD mat. So this is great because I can just hang my garment up. So again, I'm going to I have one on each sleeve. I have this banana jack here. Step over here. My ground point. I'm going to plug into the other sleeve. So I'm going to make my measurement. And you want to snap up a couple of snaps, or all the snaps on the garment too. So 3.10 times 10 to the 6th. So that's within this manufacturer. That's ours, actually. That's within our spec, and it's well below that 10 to the 9th number. So the good thing about this particular number is that I can safely wear this smock as a wrist strap, because that's going to keep me below that upper limit of 35 megohm that the wrist strap standard requires. Any other questions, Steve?
That's it for testing.
Okay, or testing?
Questions?
Yes, Jeffrey, do we have any questions right now?
Sorry, I had to get off mute there. Can you comment on grounding rods and flooring and how you would test that? I know we don't have any, but can you just comment on it, please?
Right. So when it comes to what you use for your ESD ground in your static control program, there's 3 acceptable grounds. There's the AC, or building's electrical ground, equipment ground. There is an auxiliary ground, and that's typically a separate 8-foot ground rod driven in the earth, and then my static control grounds are attached to that as my ESD ground. There's also what we call equipotential bonding, and that is, let's say this bench was sitting out in the middle of nowhere in a warehouse, and there wasn't an AC outlet in sight. I would take my mat and I would ground it to the steel leg of the bench. And so when it comes to a ground rods were typically used back in the original days of static control, when we didn't know as much as we know now. But actually the AC ground is the preferred method to ground. One is it's already attached to the building services ground rod. 2, it's everywhere. And 3, there's so much copper wire in, say, a building of our size that I'm in right now, even if the ground clamp fell off of our ground rod, I still would have a much lower potential that my static charge would bleed to. So both are acceptable, an individual ground rod or AC ground, but the standard does require that you now bond that individual ground rod back to your AC ground, and it needs to be less than 25 ohms. Any other questions?
On a larger flooring sample, so it's kind of a combination question.
Yes.
If you don't have direct access to an outlet from there, how do you test? And then also, can you remind us the tile-to-tile testing, or when you're using an interlocking mat like the one we have there, what's the I don't want to say requirement, or what's the suggestion for testing that?
Okay, well, actually, that reminds me, I didn't answer the first question completely. This is also in the second question as well. So you had asked about a ground rod. How do I check that resistance to ground on my flooring? So if I was using, oftentimes when a tile floor installer installs an ESD tile, they bury a copper strip in the conductive adhesive, and then they run it up the side of the wall and bond it to the ground of an electrical outlet. So if your floor is grounded like, I might just use this handy dandy little checker here, to plug into an AC outlet and plug my black lead of my tester in that. Now that's resistance to ground. But if it's a separate ground rod coming up through the earth, I would have just attached my ground lead to that with my other 5-pound weight on a section of floor, and that is my ESD ground. Now the challenge is if I have a ground rod, how can I check multiple points? Because my test leads are only 6 feet long, for instance. So that's really the advantage of using my AC ground, because I can pick up a ground anywhere. I could check ground on 20 points on my floor if I wanted to. So that's one of the importance of using that AC ground, because it makes it so much more convenient. Okay, when I mentioned tile to tile, and I'm saying not conductivity, but connectivity, I want to make sure that if I have an individual tile type floor, like 12-inch tiles, 24-inch tiles, that each one of those tiles is bonded together electrically. And the way we do that is with the conductive adhesive underneath it. So once I ground that adhesive with that copper strip in there, and I lay those tiles, stick those tiles down to them, that's what attaches tile to tile to tile. The same thing with my snap together floor. Once I snap those tiles together and interlock them, now each tile is making electrical connection between tiles. Another question, Jeffrey?
$4,500. Question: how does the cleanliness of floors or smocks or even mats, I guess, affect the measurements? Can you comment on that, please?
Yes, well, obviously contamination, dirt, or any type of insulative layer that's on an ESD work surface, floor, anything that we have in our electrical or in our EPA, that contamination or dust, dirt over time is going to affect the resistance of the material. However, when it comes to compliance verification, we want to test it as is. So if I tested my mat and it's got flux residue all over it, or I test my floor and it's filthy and it's good, or it's in spec, great. If it's out of spec, then what I do is I go back and I clean that surface, then I retest, because I want to make sure that it's not the contamination that's causing the problem. So you always test real world first, and if that fails, I might check to see if my ground cord's still attached, check my surface resistance. I might then clean the surface, whether it's a floor or work surface, to make sure that that's not the problem. But I always start with RTG first. Any other questions, Jeffrey?
That's it for right now. I have responded to some people, and there are a few people that we'll follow up with after the presentation, because I don't have access to the information for these questions. So let's go ahead and continue along with your presentation.
Yeah, one more thing I'm going to show you right now. I need to put my glasses on this. So while I've been taking these measurements, one of the features of our tester,
Oh yeah, I remember you telling me
unplug my smock here. One of the nice features of this digital tester is its memory function, okay? And so notice this measurement right here, and the bottom right here says save. I can save that test to the memory. And this tester has enough memory to record 100 test measurements. And so you'll see that there's also numbers, memory 1, memory 2, memory 3, etc. And so each time you save a test, it will assign it to the next available memory section. So I'm going to go up here, and I'm going to select this top one here, okay? So, I need to overwrite. So now it brings up all of the information. Tells me that it was 3.1 times 10 to the 6, gives me my temperature and humidity, and tells me what my voltage is. So again, if you're doing a lot of workstations, a lot of flooring points, things like that, rather than having to write all these down, I can save these numbers to memory and then record them back later on when I get to my workstation. So that's another really nice feature of this tester. So okay, I'm going to go back to the presentation here. Question? All righty. So, as I got to switch this. Oops. Okay. So that obviously concludes the product demonstration portion of our presentation, but I can answer more questions if you want. I've been talking about a lot of our testers. Obviously, we make these testers ourselves. Just so for those who may be new to Desco or new to us, We actually make the products that we sell here in America in our factories, and we have factories nationwide and in the UK. We have facilities in Japan. So we make just about everything we sell, design and make it. We make at least 85% of the products that we make, and we make all of our own electronics here. And one of the things about our test equipment, it comes NIST calibrated. So that's another nice feature that you get with our test equipment. I mentioned, I'm going to review just a couple of things. I mentioned this stabilization mode. Again, one of the questions was, why is the accuracy only 20% at 10 to the 12th or over? Well, that's because it just takes much longer time and a much higher voltage to get an accurate measurement. So when I have fixed voltage numbers like 100 volts, the higher that resistance gets, the less accurate it's going to be. But in our tester, at least you know it's gone into that stabilization mode and it's going to be a high reading. Again, this is a great feature here. On an analog tester, all I know is that I'm somewhere around 10 to the 9th, or I'm somewhere around 10 to the 8th, or whatever it is. But with this Mantissa feature, I know exactly what my measurement is. I know that I'm less than 1 times 10 to the 9th. And remember that in the standard, when you go through that S20.20, you're never going to see 1 times 10 to the 9th, 1 times 10 to the 10th. You're going to see less than. So if I was measuring ESD mats and I got 1 times 10 to the 9th as a measurement, I'm out of spec. I need to see an 8 or a fraction of that 8. So that's a nice feature, having this Mantissa on a digital instrument. And then for convenience also, we've color coded the LED display. So if you just wanted to run out there and make some measurements and know that I'm in the green area for a specific material or type of material, I can use that. But we've got both for you to make it easier, whether it's the LED display or the LCD, either one. And again, I just covered the memory down bottom right here. We also make these labels. So if you want to assign a numbered label to a given workstation that corresponds to your memory setting, then this is a convenient way to do that. And once again, it stores up to 100 different tests. Okay, we also, one of the things we did in this latest tester version is we went back to AA batteries. So we did have a rechargeable one or a 9-volt, but we found that people like AA's a lot better. They're much more convenient, and most of you have them within your facility. And so I like this too. Obviously, I use this. I'm an ESD technician. I do a lot of surveys, and I really like just having AA's in my test kit that I can swap out anytime I want to. So we have any more questions, Jeffrey?
We have one more on actually that picture right there. When would you use the quick test function?
The quick test function is if I don't want to wait for that 15-second delay. All right. So I can just override that right away. Or if I was measuring a material that I knew to be a very high resistance, like I did on that white Menda bottle, and it ended up being OL or over the limit, I can override that right away. I don't need to wait for that timing. And so it's still going to be over the limit, but I don't have to wait for the whole time. So that it also has to do, again, with that accuracy number. The reason why it's doing this is because it takes a lot more time to make a more accurate measurement as that resistance climbs over 10 to the 9th, over 10 to the 10th. Another question, Jeffrey?
I have a question about humidity and temperature. How does that affect the testing?
Okay, as the humidity gets lower, and in many cases colder, that can affect the surface resistance of static dissipative and low charging materials. Let's say a pink poly bag, that pink bubble wrap. The lower the humidity gets, the easier it is for that material to dry out over time. So I may want to know what that temperature is when I'm doing my compliance verification and or humidity. If I'm doing qualification, as an example, for testing some materials, I need to check at 12% and 50% humidity. So I'm going to need to control that and I can confirm that with my tester that I'm in those ranges that I need to be. But normally for regular compliance verification, that it's not a factor unless I have a failure. And then I might want to know, oh, well, no wonder I'm in the middle of Minnesota in January and it's 8% humidity. So I might want to know that, wow, this bag's been sitting out in a very low humidity climate and it's probably dried out. So that's why you want to know that temperature and humidity. Another one, Jeffrey?
That's all the questions right now, Greg.
Okay. Well, I want to thank you all again for coming. If another thing that we offer as far as our test equipment is concerned, I mentioned what we do with our ESD surveys. Some of you might have had them already, or assessment. We can come out and test all the things that I was testing today for you. Our reps can do that, give you a report. Also gives a chance, they carry most of this test equipment with them so they can demo these testers in your environment. And we also, you have other ways to view this. Obviously, we record these webinars, so they're available on our website. Go to meetings, we can do Zoom demos with you. We can do all kinds of things, nowadays in this COVID-19 environment. We can do many virtual things with you that we didn't used to do. So we've got lots of ways that you can see and how to use our products. Change mix. So if you need more information, again, my name is Greg Heckler. I'm the Western Regional Sales Manager. Here's my email and phone number. Call me anytime you like or email me, Jeffrey Brake, if you need to get a hold of him. And if you've got more questions, I'm sure we got more than we had time to answer. So we'll be answering these for you or anytime you like. So thank you for your time. We appreciate it. And we hope to see you next Thursday on our next presentation. Thank you, Jeffrey.
Greg.